everyone, welcome to our channel. So in this video I'll explain you about the problem of two-way Anova classification. Before that, as I told you in the steps, first we have to thorough with these steps. That is, first set up null hypothesis, table 1, table 2, CF, SSC, MSC and SSR, MSR, SST, SSE and MSE and F ratio. So it will be very easy to solve the problem. So question is about the following data represents the number of units of a commodity produced by three different workers. Okay, with three different workers and the three different types of machines. The data is here. So machines A, B, C, workers X, Y, Z. So the observations have given here. That is 24, 36, 30, 34, 38, 34, 23, 34, 27. So here the question, what they asked is, test whether the mean productivity is the same for the different types of machine and whether the three workers differs in the respect to their mean productivity. So we have to test here whether the mean productivity between the three different workers and the three different machines. So first let us move on to the solution. First we have to set null hypothesis, that is, there is no significant difference in the mean productivity of different types of machine. This is one hypothesis, or we can write there is no significant difference in the mean productivity of the workers. Here machines and here workers. We are testing here mean productivity of workers and the machine. So second step, we have to present the given data in the tabular form. See, this is the given data and we have to convert into the tabular form. So here workers XYZ and machine ABC, total. So how we have to present in a tabular form means, see, this data is I think for the calculation it's take more time, so we have to reduce these observations into simplest, small numbers. So I have taken here 20 as the number for the subtraction of all these numbers. So 24 minus 20 is 4, and next, see, 36 minus 20 is 16, and 30 minus 20 is 10, have written here. And same for X and Y, we have to subtract for 34 minus 20 and 38 minus 20, 34 minus 20, 23 minus 20 and 34 minus 20, 27 minus 20. We'll get these values after subtraction with the number of 20. So we have to total with rows wise also and column wise also. A is 21, B is 48 and C is 31, and same as for workers, X is 30, Y is 46 and Z is 24. When we total this side and this side, the both values should be same, that is 100 I got here. So next we have to calculate table 2. It's not just we have to what we have calculated the values in the table 1, just we have to square up those values. How means 4 square, 16 square, 10 square, 14 square, 18 square, 14 square, 3 square, 14 square, 7 square. See, after square of those numbers, we'll get these values. Same, we have to total in row wise also, column wise also. Same again, we have to grand total these values. We'll get both sides same, that is 1342. This is the third step over. So next we have to calculate correction factor. How to calculate correction factor? The formula is t square divided by n. T square means total of, in table what we have calculated, this is the total 100. 100 square divided by 9, that is CF is 1111.11 will get as correction factor. So next we have to calculation of SSC, that is sum of squares of columns we have to take up. So here how many columns we have? 3 columns we have. So the total of first column, total of second column and total of third column. First we have to take the totals of columns, that is here. From the first table 1 we have to take total of, this is columns, this, that is A, B, C, this total 21, 48, 31. You have written 21, 48, 31. So square we have to 48 square, 31 square divided by 3 observations. Why? Because here we have 3 observations, 1, 2, 3 observations. So we have to take the value as 3. So 21 square divided by 3 and 48 square divided by 3, 31 square divided by 3 and minus correction factor, that is 1111.11. We'll get these values. After substitution of these values, we'll get SSE as 124.22. So next step, we have to calculate MSE, mean sum of squares of columns. So that is SSE divided by degrees of freedom. What we have calculated, the SSE value we have to take, that is 124.22 divided by 3 minus 1. How 3 minus 1 means? We have 3 column side, that is 1, 2, 3. So we have 3 columns. We have taken here 3. So 3 minus 1 is 2. So 124.22 divided by 2 means 62.11 we will get. So next step, it is calculation of SSR. Same as we done in column SSC. Same method we have to use for SSR. SSR means just the values we have to take from the row wise. That is total of first row whole square and total of second row whole square up to how many and third row. Here we have 3 rows. So we have to take 3 rows value divided by observations and minus we have to do correction factor. So these values also we have to take in the table 1, that is row. This is the row X, Y and Z. This 30, 46, 30, 27. See, I have taken here 30, 46, 24. Just we have to square up this, and after squaring we'll get these values and divided by 3. As I told, we have 3 rows. I am taking the value as 3 here. This is the order what we have to follow while calculating the SSR. So 900 divided by 30 is 300. 2116 divided by 3 is equals to 705.33. So 576 divided by 3 is equals to 192 minus correction factor. Should not forget to minus the correction factor. After the substitution, we will get SSR is equals to 86.22. So next 8th step is about MSR calculation. MSR means mean sum of rows we have to find. That is SSR, what we have calculated here. This value divided by degrees of freedom. So we have 3 rows, right? So 3 minus 1 and the SSR value is 86.22. After the substitution, we will get 43.11 is the MSR. So next step, 9th step is calculation of total sum of squares. That is SSC. In this is very important. Grand total of sum of squares. Where we have to take grand total. This is the grand total. That is in table 2. In table 2, we have to take the total, grand total. That is 1342 minus correction factor. When we substitute this, we'll get SST as 230.89. So next we have to calculate residual, that is SSE, sum of squares of errors. That is SSE formula is equals to, this is the formula, SST minus SSE plus SSR. What we have calculated SSE and SSR value, we have to add, and we have to divide this value with SST. That is SSE is equals to 230.89 minus 210.44. That is SSE is equals to 20.45. So next 11th step, that is calculation of MSE, that is mean sum of squares of errors. So MSE is equals to SSE. In the previous step what we have calculated, that value we have to take here 20.45 SSE divided by degrees of freedom, that is C minus 1 and R minus 1. We have 3 columns and 3 rows. So 3 minus 1 and 3 minus 1. After this calculation, we will get 20.45 divided by 4. Here 3 minus 1 is 2, 3 minus 1 is 2. After we have to multiply this 2, we'll get 4 as answer. So after the 20.45 divided by 4, we'll get MSE as 5.1125. This is the MSE value. So last step, 12th step, that is we have to calculate F ratio, that is between columns and between rows. So MSE mean squares in the columns divided by MSE errors. MSE what we have calculated, this value we have to take, and we have to take those value and we have to divide. We will get F ratio as 12.181486 we will get. So next, F ratio between the rows, MSR divided by MSE. That is, MSR value is for 3.11. What you have calculated MSR, that value only you have taken here. What to take here, divided by MSE. That is equals to 8.43. So next, how we have to find value for the table value, that is V1 and V2. So V2, while calculating MSE, we got this as the degrees of freedom 4. That value we will take as V2, and V1 is 2. How means while calculating degrees of freedom here, calculation of FSR, we got degrees of freedom here also 2. We'll get 2 here, and as the calculation of MSC also, degrees of freedom is 2. We'll get here 3 minus 1 is 2. So both are 2. So for that we'll take V1 as 2. So how to find out critical value means, as I told, we have to see F distribution table at 5% level of significance. V1 value is 2 and V2 value is 4. We have to find the table value. So V1 is 4. Sorry, V2 is 4 in this, and V1 is 2. So both will interact in this value, 6.94. This is the critical value for the 5% level of significance. So table value we got. So we have to write the conclusion. So the value of computed F ratio between the columns is 12.5 and rows is 8.43. The critical value for V1 is equals to 2 and V2 is equals to 4 and 5% level of significance is, we got 6.94. So compared to both this, the critical value is less. So the calculated F ratio value is higher than the critical value. Both the value when we compare the F ratio with the critical value what we have taken in table at 5% level of significance, that is higher. That is higher than F ratio is higher. So here null hypothesis rejected. So decision, there is significance difference in the mean productivity of the machine and mean productivity of the workers. After this we have to present the Anova table. As I told, what we have calculated in the problem, just we have to present that values in the Anova table, that is sources of variation between columns and between rows and the residual value. So sum of squares, that is SSC value I have written here, SSR value we have written here, and SSC value. So next, degrees of freedom, that is 3 minus 1 is equals to 2. Next, r minus 1 is equals to 2. Here same, 3 minus 1 2 will get both as 2. 2 into 2 will get 4. Next, mean sum of squares, that MSC value and MSR value and MSE value. So F ratio what we have calculated between the columns and between the rows have written here both. Just this is the way we have to present the Anova table in the classification of two-way Anova. If you have any doubts in this, just you can comment in a comment box, or if you want to give any suggestion to this video you can give. So for more videos, subscribe to our channel. Thank you.